Hi everyone, this is JS Visa, and I come. Background. Working on state DB and to replace the transitions. This is really slow and it costs a lot of CPU. So we want to introduce a real-time tracing system, which will offer more efficient and promote insights into the EVM execution, and it will also support indexing the left execution data, such as the traces, the state diff, and the other things. So let's see how can we go to how to index those left data. Currently, we support indexing the traces, which is grouped by a block, and so this is a block number and minus 2 the traces, and as indexing is based on the nonce. This is we want to index the transaction sender's address plus its nonce to our transaction hash. In my implementation, I'm using KVDB used to store newly created block traces and nonces. This is just a genetic KV database, and I use the ETI-DB in Geth. For the king schema, for the traces, it is just a block number plus block hash and the trace tab. And for the nonce, it is used the king schema is the transaction sender's address plus its nonce, and the value is just ILP encoded data. So the implementation is very small, very simple, and for trace tapers, currently we support the code tracer and other traces such as the parity trace and the preset tracer. Here is the workflow of the indexing, and for each block, we will index each transaction based on the T-star starter hook. And in that hook, we will to see if we enable the nonce tracing. If so, we first store the nonce traces in the KVDB. And if not, we just continue, and for each transaction end, we get the transaction result in our local trace, in our local cache. And when the block is ended, we will store the block traces into the KVDB. And in the meantime, we will notify our other background freezer to notify him we have just indexed a new block. And the freezer will freeze the newly created traces into RDB for the efficiency. And so this is just for the indexing, and let's see how can we retrieve those data. For the traces, we can retrieve it by the block number and the block hash. And for the transaction hashes, for the transitions, we can fetch the block first by the transaction hash, and then retrieve it by the block number and fetch the transaction hashes data by its index. And for the nonce, it is really simple. We can just retrieve it by the sender's address and the nonce. And here is just a small workflow of the block traces retrieve index. Yeah, it's really it's very simple. Just read the block number first and check the block data in is whether in the KVDB or in the first DB, and then return back to the column. So how can we use this feature? As currently, this feature is not merged into the mainnet, into a master branch. So if you are interested, you can follow this PR and see how to use it. the left side is the configuration of the to enable the feature. You just need to add source, something like that in the left side. And on the right side, I will introduce every configuration. The first one path is just a dictionary which is used to store source data. And the second one, enable NAS traces, is index the left trace with to enable the NAS trace or not. And the third one, must keep blocks, is just a block limit. So after such blocks, we will point all the data just to save disk size. And for the config, it's a map. It's a map to configure each tracer. And for each details, you can refer to the built-in Geth's built-in traces for more detail. Okay. Currently, we support those RPCs. It's like the parity trace RPC, and the last one is the RPC. This is just proposal, and it is not enabled for other clients, I think. Besides of the parity's code tracer, we can also retrieve other Geth's native traces. I think it is really useful when you want to get the history data or history police data for one transaction or one block. We can just like this JSON-RPC. In this example, we need to retrieve the police data tracer for the block 1. Yeah. So next we can just talk about the performance. Yeah. Before we talk about performance, in my mind, performance is just a space and time trade-offs. In this implementation, we just use the low-cost disk to store the data instead of the high usage of the CPU. So, for the advantage of the feature is just you no need to reapply the traces based on the data, and the time computation is very small. It's just 0.1, and the retrieving is real time. You can index the data and then retrieve it back. And the disadvantage is you need another disk space to store this data, and it may have a little impact on the on-chain block syncing. Yeah. Here I just write some benchmark to compare the results of the trace RPC and the debug RPC. Yeah. It's a script to run to retrieve the data from the Geth with the JSON-RPC. And this is a results of the JSON-RPC results. The upper one is the traditional debug trace block, and the later one is the trace block. It is about 100 times faster than the traditional one. Yeah. That's all. Thank you.
Thank you very much. Your question?
Sure, yeah. Hey, thanks for this. Really appreciate it. I think as a developer, it's sometimes confusing because there's no standardization on the debug or trace namespaces, right? The other RPC methods are in the execution API, so they tend to be standardized across clients. When you move to debug tracing, it becomes a bit trickier. Other than performance, because some clients are going to implement debug, some implement trace namespace, some do both. Other than performance, like, why would you recommend trace over debug? Is there other reasons you would recommend that option for tracing?
It's more customized. You can just index the data by your need. Yeah, and because the traditional debug trace, which is also only supported such as the parity trace, the code trace, and the flat code tracing. And if you want to index other things, you might need to write a JS tracer. Yeah. And the performance is really very, some part is not very good. So in this situation, we just introduced the living tracing framework, and based on that, you can just write your own traces.
Right, thank you. I have another question unless someone else maybe.
Probably missed it. This will be integrated into Proc, or when it's going to be added to Geth?
Actually, I'm not sure. Yeah, maybe this feature will be merged into the master branch and in the fall, or maybe when the no need to hard fork. Yeah, just attention.
Maybe can you touch real quick on the, you were talking about some potential issues on the syncing side. You had your second bullet point on the slide where you had pros and cons.
Sorry, I can't come back.
Do you remember? There was like two cons you mentioned. One was like additional storage space for trace was one of the disadvantages. And then the second one was, you said potential syncing issues.
Yeah.
Can you touch on that or go a bit more and just explain what you meant by that? Or like at least, I guess, what you observed when you were benchmarking?
Actually, this is not inside the presentation, and I will attend it and maybe in other works. Yeah, thank you.
Thanks.
Next.
So most of the speed improvement looks like it comes from caching and indexing the data. Did you look at indexing the built-in native debug trace?
You mean the debug trace?
Yeah, the pre-state and the call tracer, so that you're basically saying half of the argument is it's faster, but most of that I suspect comes from the fact that you're indexing all the data. Did you look at indexing the debug trace calls as well?
I'm sorry, I haven't fully answered that.
So most of the performance increase comes from
translation reply.
No. Oh, really?
Yeah.
Not from the index.
No,
Not from indexing the data.
Yeah. Actually, the performance is really depends on the history data. Yeah. You need two features. All the history data need to replace the translation, so the performance is really yeah. Because the disk feature is really slow. Yeah. Sorry.
I guess like piggybacking on that question, like the improvements that you shipped with trace, the train namespace, could you not backport them to debug as well, or is that not possible?
Yeah, because in the left tracer, the data is just generated and stored on when the transaction is executed once. And when you use the debug tracer, the data is just replied when every time when you request it. So in this implementation, we just store it once and feature it at any time.
That's right, but you're talking specifically about the live tracing here, the real-time tracing, or you're also speaking about when because when you had that graph that was showing 100 milliseconds for trace block, right? And then you had debug trace block at the top. That wasn't for live tracing, right?
Yeah.
That was just historical calls or where you can trace any block, correct?
No. Actually, for the tracing, you need to index source data first. Yeah, just after the gas is started.
We gotta cut it off here.